So just make sure you were right. I'm sure you all were, because as I looked at you holding them up, you were right. Triple the amplitude would be taking the amplitude and tripling it, which would be 9, correct? Yep. And then it did not say anything about, it could. There are ones that say the period is half the amount, or takes half the time, or twice the time. So write the equation. But remember, that's not period. A lot of you got this one wrong on the quiz where I did change the period. That's B, which affects your period. Does everybody see? So if that was true, you'd go off to the side, find the original period, you would double it, and then find a new B. Or if you can just see it in your head, but some people can't. So it didn't say anything changing about that, so we would say pi halves x still, and then decreasing the midline by 4. That shifted down 4. So as you can see, not super advanced. So everybody feeling good? Okay, let's get to today's lesson. So we're just learning some these are our final identity or formulas that we can change things, switch them back and forth. Now, what's hard about today is you really don't know which one, you really don't know until you see the problem which way you should go. So you do have to just kind of think critically. So these are what are called double angle formulas, because twice the angle, double the angle. Does that make sense? You already have these on your formula sheet, so I'm really not going to spend a lot of time on this. So sine of 2u can be rewritten as 2 sine u cosine u, and vice versa. It sometimes is useful when solving if you see something of this to switch it back to this, because we know how to solve this, right? We just solve it like normal and then times our answer by a half, right? Yeah. So you can switch back and forth. There are times when this is better. It just depends. Cosine of 2u can actually be switched to any of the three. This or this or this. Now the problem is, which one should you switch it to? Honestly, there's not a right or wrong answer here. It's just one of them is going to help your answer simplify a little bit prettier. If you choose the wrong one, you're not going to know it. It's just the simplification won't go out as nicely. You don't. You make your best guess and see. You look at the equation and you make a good decision based on what you're seeing in the rest of the equation. So if you see a bunch of cosines, wouldn't you probably just do the cosine? If you saw a bunch of sines, you'd just do the sine, you know? So tangent of 2u is 2 tangent u divided by 1 minus tangent squared of u. Or you could do, like if you have a tangent of 2u, you can find sine over cosine of 2u and then divide them, but it just depends on what you like to do. Double angle formulas. You can switch back and forth. So now we'll just start practicing these. So it says solve 2 cosine of x plus sine of 2x equals 0. So remember with solving, you isolate the trig function, and then you change everything to be all sines or all cosines, hopefully. Or you factor out things if you can. But looking at this right now, there's nothing we can factor out. And they're not all sines, not all cosines. So at this point, we would not be able to solve it. So what you would recognize is, oh, this is a double angle. That can be rewritten as something else. That, right? That was what I just gave you, one of the formulas, which you have on your sheet, what I need to see everybody's out. So we would say we still have a 2 cosine of x. And then this became plus 2, and then it was sine of x, cosine of x, because that was the identity. Do you see it? And that's equal to 0. And now you could look at it and say, what can I do to solve this? What should I do? Yeah, we should factor out 2 cosine of x, because that's in common. Divide by 2 cosine of x, divide by 2 cosine of x. That's nice, because now we have a 1 plus sine of x. So now we've set each of those factors equal to 0 and solve. 2 cosine of x equals 0, 1 plus sine of x equals 0, and then we'll solve for x. So divide by 2. When does cosine of x equal 0? And I'm going to write this one while we're at it. When does sine of x equal -1? So it did not say an interval of which we're solving, so we're going to find all solutions. So everybody, cosine is x. Look on your unit circle. When does cosine equal 0? Okay. So at pi halves and 3 pi halves. And then we could put plus 2 pi n, but that would not be how we would list it. Can anyone tell me why? With which one? You're right. Okay, so you're saying this would take care of it. If we just said let x equal pi halves and then just add only pi, and that would take care of being up here and then down here on our unit circle. So we would say pi halves plus pi n, and then remember that thing we talked about where n belongs to the integers, which integers means positive, negative, and 0. So where n belongs, it's like a fancy e, and then to the integers is a fancy z. So there's our one solution. And then when does sine equal -1? Does that work?
Yeah.
Have we already listed that solution?
Yes.
Yes, because this does contain 3 pi halves. We would not need to list it again. There's our answer. Next one. You get what I'm saying? Because that actually takes care of that solution down. Okay, let's look at this one. Y equals 4 cosine squared of x minus 2. Now here's the thing. We have not graphed cosine squared, have we? We've only graphed cosine. We want it to be just a cosine because we know how to graph just cosine. So I look at this and say, well, what can I factor out? The 2. So then divide by 2, divide by 2. So then left is 2 cosine squared x minus 1. Now you have to have a really keen eye because then you should notice, oh, you know what? That is an identity we learned today. So look, this equals this. Isn't that that? So can't I take this and rewrite it as that? So this is equivalent to y is equal to 2 times by cosine of 2x. And now we know exactly how to solve this. Answer these questions. We don't even have to graph it. What is the amplitude? 2. We would answer it's 2. What is our period? Yep, you got that by 2 pi over b, which is pi. You're correct. What are our max and min values? Now, if this was on an interval, like we could graph it and then we'd have our cosine or whatever, and then our max values we'd be able to say x, y points, but it didn't stand on an interval, you know? So I'm thinking they're more just going for what you just said. Our max and min values are 2 and -2. Our amplitude's at -2 up to 2. So I agree with you. From -2 up to 2. Our x-intercepts for all functions, guys, for all functions, an x-intercept is when y equals 0. So we're really looking for when does 0 equal 2 cosine of 2x. And then isn't it just solving like we've been doing all along? So wouldn't we isolate the trig function? So we divide both sides by 2. So we'd say when does cosine of 2x equal 0? Then we pretend the 2 is not there, right? We solve it like normal and then put that in, take that into consideration. So we just answered this. Wasn't our answer our cosine equals 0 at, you said pi halves, didn't you? Plus pi n, isn't that what we just said? So now we would say it's not x though, it's 2x. So you're timesing both sides by half. So x is equal to pi fourths and then plus pi halves n. There's our zeros. Yeah, good point. Good reminder. We need to hurry and add in our n, e, z he's saying. N belongs to the integers. Okay, doing good. Okay, I'm going to give you a second to write this one down possibly if you need to. So we're given, it says find sine of 2 theta, cosine 2 theta, tangent of 2 theta. Given that just cosine of theta is 5 over 13. People will think you can double that, but that's not what you can do. I don't know. I'm trying to think of their thought process. That's not theta, so you can't double it. You know what I mean, everybody? So we're given that cosine of a theta, so that must be a right triangle then, everybody. We have some theta, and the cosine is adjacent over hypotenuse. So that's 5 over 13. Now, I'm not drawing this in a quadrant, and I probably should be, so I'm going to push pause. We're told our triangle is between 3 pi halves and 2 pi. So my triangle is actually right here, is it not? So then we know this is 13, and then x was 5. Does everybody see? So now we would do Pythagorean theorem to find the other side, because we probably might need it. 13 squared minus 5 squared, you take the square root, you get 12. So now we can actually go through and list out what sine of theta is and what tangent of theta is. We know cosine's that, so then sine of theta is, oh heck, so isn't that 12 over 13? What am I missing? Negative 12. Thank you. And then tangent of theta is opposite over adjacent, correct? Yes. So negative 12 fifths. Okay, perfect. So now it says find sine of 2 theta. So we'd say, okay, well, we know only sine of theta, and we know cosine of theta. So do you see how going from here to here would be useful? Because we know those two things, if there's not a 2 in front. So we'd say sine of 2 theta is equal to 2 sine theta cosine theta. Let's plug in what we know. 2, what is sine of theta? Negative 12 over 13. What is cosine of theta? 5 over 13. Then I would just want you to type it into your calculator, math, enter, enter to be quick. So now we could say sine of 2 theta is negative 1 over 169. Okay, cool. There's sine of 2 theta. Let's answer what cosine of 2 theta is. Now, with cosine of 2 theta, remember there was 3 different things we could change it to be? Everybody? I literally randomly am choosing just one of them because not really any of those is any easier than the other one calculating, I don't think. Does everybody see what I'm saying? So I randomly chose that one. So that's 1 minus 2 sine squared of theta. So you'd say, okay, let's plug in what we know. 1 minus 2, and then sine is negative 12 over 13, and then that's squared. So now you type that into your calculator. So then cosine of 2 theta is perfect. Now we could do tangent any number of ways. We could do the formula, or we could remember that tangent is sine over cosine. It was in the form, you know those 3, look at cosine of 2u. There were 3 things we could change it to be. I randomly picked one of them. Because this is sine of theta squared. Well, it's, okay, great question. So Adam's asking, but just a reminder, this is no different than this. It's just how they write it. Okay, okay, everybody. So we can now say tangent of 2 theta. I'm going to do it the easy way. I'm going to do a sine over cosine. So my sine was negative 120 over 169 divided by negative 119 over 169. Dividing fractions is easy as pi. Flip a second and multiply. So tangent of 2 theta is, good, 120 over 119. His negatives divided out. Does everybody see? And the 169's divided out. So that would be our 3 answers. Okay, we're doing good. Okay, let's look at this one. So it says simplify sine of 3x. Now what this is doing is it's giving you a hint of where to start. It doesn't say prove the, or it doesn't say verify this. So we're not verifying that. It's saying simplify this. So it's saying simplify sine of 3x. A lot of times they won't give you a hint. You'll just have to see, what could I do here? How could I split this up or rewrite it as something I know? So they're giving you a hint. Think of sine of 3x as sine of 2x plus x. So they're telling us where to start. So the first thing you should notice is, oh, this is an addition of a sine. We learned that last time, true? So this is sine of u plus v. So now we would first have to split this up with our formulas from last time. So we remember our formulas with addition for sine. Sine on the outside, cosine on the inside, and then it goes uv, uv, right? And then the sign for sine stays the same. So you'd say, okay, I've done my first step. That is as simplified as I can see for a second. But now you would be noticing, oh, and now I have a double angle formula we just learned today. So we can literally rewrite that as 2 sine of just x cosine of just x. So everybody sees. Because that was an identity we learned today. And then we still have times by this cosine of x right here. So isn't this 2 sine of x, and then it became cosine squared x? Okay, so I'm just going to tell myself, yep, I have done all that stuff, so I remember what I have and have not done. Okay, let's look right here, cosine of 2x. Now the question is, so remember there were 3. The hard thing is which one is going to be the best for this problem to simplify it down. There's not a right or wrong answer. I mean, if you pick one, it will all simplify to be the same thing. It's just one might simplify quicker and easier. So you look at those 3 and see if you can see what one you might want to use. What is the second one? Good thought. Do you want to go with the cosine one? You want to go with the sine one? Do you want to go with the cosine squared minus sine squared? No one has a preference, huh? Besides Joseph and Alan. There's not a right or wrong answer. I'm just waiting to see what everybody thinks we should do. Okay, so you're saying that you feel like let's try 1, so then we have a plus, and then we have a parentheses, 1 minus 2 sine squared x, which is that, and then we still have times by sine of x. Okay, let's look at our problem. Now, I'm looking at this and I'm seeing a lot of sines. So, good point. Let's probably change our cosine squared to be sine if we're seeing so many sines. So, we have 2 sine of x. You're having to keep your algebra really nice and pretty so you don't get lost in it. And then right here is 1 minus sine squared x. And then right here we still have plus all that stuff. Now, next thing I'm noticing is I'm thinking, maybe I have like terms I can combine, but I don't know if it's factored. I need to have it in standard form. See how this isn't multiplied in? Like if we put it in standard form, we can combine things that are alike. So let's do that. Let's start distributing. So 2 sine x times 1 is 2 sine of x. 2 sine of x times negative sine squared of x is negative 2 sine cubed of x. X sine cubes of x. There's 3 of those, right? What's x times x? Okay, we have x and we have an x squared. We just write it right here, which is the same thing. Okay, so now we have sine of x times that, sine of x times that. So then we have plus sine of x, and there's not a negative, so I don't need to distribute, so just watch out for things like that, though. So, and then we have minus 2 sine cubes of x. Okay, let's start combining things that can be combined. 2 sines of x's plus 1 sines of x's is how many sines of x's? 3 sines of x's. Negative 2 sine cubes of x minus 2 sine cubes of x. Negative 4 sine cubes of x. So now I'm looking at this and I'm wondering, can we simplify this more? Or if we keep going, is it going to make it worse? That's the hard thing, is knowing when to stop. So we could see, what could we do? I'm going to put a star by it because I'm like, that's really all I can see happening here. But let's check. So what are you saying? I heard some of you say, well, let's try something. So you're saying, let's see if that helps us. If we factor out sine of x and then divide by sine of x, let's see what that gives us inside. That would be 3 minus 4 sine squared of x. That's a good question. I'm looking in here and I'm like, nothing prettier happened here. I'm not going to want to change it to cosine because then I'm going backwards, you know. So I'm like, you know what? If I keep going, I'm just undoing something. So I'm done. So is factored form or standard form, is one better than the other? No. So either one is acceptable, but that's really as far as you should go. So I'm just going to go, ding, there's my answer. Okay, we're doing good. Okay, so these are the last formulas we need to learn, and we're almost done with the lesson. So these are the half angle formulas. So everybody, why are they half angles? Because look, the angle divided by 2, the angle divided by 2, the angle divided by 2. So we have a lot of formulas to memorize for this unit, don't we? Yep. We'll be okay though. I'm going to ask Roberts to see if he's giving any, but last year we didn't, so I don't know why we would this year. I'm going to go make sure I do the same thing he does. We should be the same. Anyways, so everybody, it's sine of u over 2 can be rewritten as this, and this can be rewritten as this. So it's equal to plus or minus. You will not put plus or minus. It's either plus or minus depending on the quadrant that your original degree is, depending on that. Okay, so then this with sine is, notice it's cosine, and with cosine it's cosine. And with sine it's negative, with cosine it's plus, and then tangent could be either of these. It does not matter which one you use, you would use whichever one will help you better for the problem. Okay. Here we go. Ready? Okay, it says find the exact value of sine of 105. Now remember, if you got to a test, you actually have a few options. It does not specify how to do this. So couldn't we see if two things add up to be 105? That's almost easier, isn't it, than the half angle? But for this lesson, we're going to use a half angle formula. So 105 is half of what angle? It's on the unit circle. 210. Does everybody see? So this is equivalent to, we could think of this as sine of 210 degrees divided by 2. Those are equivalent statements. Now 105, we're going to go with the original. Which quadrant, because we're finding the answer of the original. Does everybody see? We're finding the sine of that. So which quadrant is that in? 2. So over here, cosine is negative, sine is positive, right? Okay, so just remember that. Okay, so we can rewrite this as, well, now my u is 210. So let's plug in what we know. So we have, let's just come back to the negatives, positives and negatives in a minute. So we have 1 minus cosine of 210 divided by 2. So what is the cosine of 210? Oh. No. You go with the original. This is 210 divided by 2, which is 105. Here's what's dawning on me. Okay, sine is, sine is y, correct? Or yeah, or opposite, whatever. But so we need to be putting a what sign in front? No, sine is positive. We're finding the sign at that. Does everybody see? Last hour, I think we on accident said negative. So it's positive because sine's positive. So now cosine at 210. Let's keep simplifying this. 1 minus, what is the cosine at 210? So negative root 3 over 2 divided by 2. You have got to be excellent algebra mathematicians. Let's keep simplifying this, noticing this goes clear down. So now what I would say is we have this, showing all my work, the square root of 1 plus root 3 over 2 all over 2. True? You can't flip the second and multiply until you have one fraction divided by one fraction. So to get one fraction right here, you need to do a common denominator. So 2 over 2. So we have the square root of 2 plus root 3 over 2. That took care of the top. And then over 2, and I'm going to go call that over 2 over 1. That was this. Everybody sees. So now dividing fractions is easy as pie. Flip the second fraction and multiply. We're going to take this up. 1/2. So we have the square root of 2 plus root 3. Don't we multiply straight across? All over 4. Now because we have a fraction on top, we just have a fraction here, we can split up the top from the bottom, which is a good idea since the 4 can simplify. So we have the square root of 2 plus root 3 all over the square root of 4, which is 2. And then do we even need to rationalize the denominator now? Nope. So there is your answer. That's the sine at 105. We're still able to use the unit circle to give an exact answer. So on top we have the square root of 2 plus root 3, and on bottom we have the square root of 4, which is 2. Okay, so that feels like an ugly answer, but it's not. And then everybody, you can't just square root that and that. That would be breaking the forbidden rule, because that's really to the 1/2 power. You can't 1/2 that and 1/2 that over an addition sign. That's as good as it gets. That is an exact answer. If you typed into your calculator the sine of 105 in degree mode and compared it to this decimal value, they would be equivalent. This is just the exact answer. Okay. Okay, this is my last example. Find all the solutions of 2 minus sine squared x is equal to 2 cosine squared of x over 2. So, as we look at this, when solving, we want all sines or all cosines, true? And then we definitely don't want an x over 2, so let's rewrite this. So, I am going to just start with this side since I'm seeing there's a half angle. So over here for right now, I'm going to leave it. 2 minus sine squared x is equal to, that 2 is just times by the cosine of the half angle. So we still just have a 2 in front, times in front. So then this piece is squared. So we can put the squared out here. So what is cosine of u over 2 or x over 2? This, true? So, and it says find all the solutions on the interval from 0 to 2 pi. So isn't cosine on that interval plus and negative? Aren't cosines positive and negative? Wow, I'm just getting smarter as the day goes on. I didn't say that first hour, we didn't even talk about it. Okay, so we have plus and minus the square root of 1 plus cosine of x over 2, but wasn't that squared? Sweet. So let's simplify this. 2 minus sine squared x equals, we have our 2, and then times by, isn't a positive squared and a negative squared positive? So we don't have to worry about that anymore. What's the square root? Squared. It's gone. Doesn't root cancel out powers? So then we have 2 times, we still have that on top, that on bottom. So we have a 1 plus cosine of x on top, and on bottom a 2. The 2's cancel out. So our true statement right now is this. 2 minus sine squared x equals 1 plus cosine of x. Now you say, we solve by getting them all cosines or all sines. The only one we can change is sine squared to be a cosine. So shouldn't we change this? So we have 2 minus parentheses. People mess up on little things like this. Minus, if that became 1 minus cosine squared of x, which it does, we've got to distribute the negative in a minute, equals 1 plus cosine of x. So now we have 2, distribute the negative, minus 1 plus cosine squared x equals 1 plus cosine of x. 2 minus 1. 1 plus cosine squared x equals 1 plus cosine of x. You see, I'm just combining like terms. So then what? You tell me. How do we solve an equation? Okay. Isolate the trig part, correct? So, and get it set equal to 0 if it's going to be factorable. So we're going to combine my terms, subtract 1, isn't it gone? So we have cosine squared of x equals cosine of x. So you'd say, I solved these by getting them set equal to 0 and solving by factoring possibly. Subtract cosine of x. So we have cosine squared x minus cosine of x equals 0. Now I can factor out a cosine of x. These problems are kind of long. Factor out a cosine of x, divide by cosine of x, divide by cosine of x. Then left is 1, what is it? Okay, good save. Cosine of x minus 1 equals 0. So now can't I set each of those equal to 0 and solve? When does cosine of x equal 0? When does cosine of x minus 1 equal 0? So when does cosine of x equal 1? When does cosine equal 0? We've already done this 3 times today. Pi halves and 3 pi halves, but we're just going to call it pi halves plus pi. Oh, wait, this said on an interval, didn't it? From 0 to 2 pi. You don't have to worry about this, but we do actually need to list out 3 pi halves, don't we? Well, but then you'd have to specify it. N is only on quad the first. That's harder than just writing out the 2 solutions it is. Does that make sense? Because it said find all the solutions on an interval from 0 to 2 pi. So there's our first 2. And then right here, when does cosine of x equal 1? I think it only happens in one spot. Oh, I see what you're saying. 0 and 2 pi. 0. Okay, and let's look at what this says. Okay. Which one had a parentheses? Which one had a bracket? 2 pi had a parentheses. That means not including 2 pi. So we would just do 0. Holy cow, I bombed this lesson first hour. I don't even remember saying that. I know we didn't say that. Okay, well, sorry first hour. I hope you're watching this video. Okay, anybody done? I mean, anybody questions? It's just hard stuff. It just comes with practice. So you have 45 minutes to practice, and I mean, you have 45 minutes. You need to be actually doing today's assignment right now. Go.